In this example, we're going to graph one cycle of the curve shown, and then we're also going to state the amplitude, period, phase shift, and axis of symmetry. So the first thing we want to do is make sure that we factor out the 3 from the input. And by doing that, it allows us to determine the amplitude. Now the amplitude is the absolute value of A, the absolute value of 4 is 4. The period is 360 degrees divided by the absolute value of K. Well, the absolute value of 3 is 3. 360 over 3 is 120 degrees. The phase shift is going to be 15 degrees to the left, and the axis of symmetry is going to be at y equals -5. Okay, so we've got all this information, and what we're going to do now is do our best to plot it. But before we do that, we're going to try and remember that the key interval will be the period divided by 4, which it always is. So the key interval is going to be 30 degrees. So coming back to the next slide where we're going to be graphing it, we see that the amplitude is 4, the period is 120 degrees, the phase shift is 15 degrees to the left, and the axis of symmetry is at y equals -5. But it's important for us to know what's the parent function. And going back to this last question here, we see that the parent function is going to be positive sine x because there's a positive number in front of the sign. Okay, so what we can then do is ask ourselves, what is one cycle of a positive sine curve looks like? Well, a positive sine curve, like all of the curves, is going to have 5 key points. We see, as with every one of these curves, that the x-coordinate of the first point will be d. The x-coordinate of the second point will be d plus a key interval. The x-coordinate of the third point will be d plus 2 key intervals. The x-coordinate of the fourth point will be d plus 3 key intervals. And then when we add another key interval to that, we'll be able to say we've added 4 key intervals, or in other words, 1 period to d. Now, if you look at this, the first, the third, and the fifth points of those key points, those are all on the axis of symmetry. So we can say every one of them has a y-coordinate equal to c. Now, the second key point, that's up at the maximum. That's 1 amplitude above C. And the fourth key point, that's down at the minimum. That's 1 amplitude below C. Okay? And so we're able to say that these are going to be the 5 key points. Now, the phase shift is 15 degrees to the left. That means D is equal to -15 degrees. The C value is the same as the Y value of the axis of symmetry, which is -5. Now, since the period is 120 degrees, that means the key interval is equal to 30 degrees. So we can say that D plus a key interval is -15 degrees plus 30 degrees, which is +15 degrees. Getting to our next x-coordinate, we're going to add another 30 degrees to that. To our next x-coordinate, we're going to add another 30 degrees to that. And to get to our next x-coordinate, we'll add one more key interval, another 30 degrees to that. Okay, now our y-coordinate is going to be -5 at the first point, and the third point, and the fifth point. It's going to be at the maximum value of -5 plus an amplitude. So -5 plus 4 is -1. It'll be at that maximum y value at the second point, as we see here, but it'll be at the minimum y value of -5 minus an amplitude, which will be -9 at that fourth point. We have a lot of negative y values, So we're going to make our x-coordinate be, sorry, our x-axis be up near the top to give us a lot of room with negative y values. Now, our lowest common factor of all these x values is 15 degrees. So what we're going to do is we're going to let the scale of our x-axis be 15 degrees, and we're going to let the scale of our y-axis be 1. Okay, now negative 15 degrees, comma, negative 5. Negative 15 degrees will be to the left of the y-axis. Negative 5 will be down there. 15 degrees, comma, negative 1 will be here. 45 degrees, comma, negative 5 will be here. 75 degrees, comma, negative 9 will be down there. And finally, 105 degrees, comma, negative 5 will be there. And we do our best to draw it without making it look rigidly straight. It's a little bit hard to do that sometimes on this tablet that I'm using, but we'll do our best. And we've now answered the question, because the question only asked us for one, to graph one cycle. But we know that these curves, and it'll be important to know this, they go infinitely in both directions. And so we could come up with some accurately sketched points if we wanted to. And we'd be able to draw more than one cycle if we were ever requested in another question.